we're given two different forms of the variance formula. Okay? And it's really useful to understand how we can get between one and the other, or how the second one is derived from this one. Okay, so we know that for each x, if I find the difference between each value of x and the mean, I square it, and then I sum up all those values and divide them by n. That will give me the variance. Okay, and if I take the square root of the variance, I get my standard deviation. Right, so this is good if I have a few discrete values of x. It's quite easy to calculate. But if I've got lots of values of x, it becomes a bit unwieldy. So then the other form is given. So if I'm going to get from this to the other form, what can I do? Well, I've got something squared. So what we can do is we can expand out the thing that's been squared. So if I do that, I've got x squared minus 2 times the mean times x plus the mean squared. Okay, and this is still being divided by n. Okay, well, remember, we're just adding these things up. So that means now I don't need the brackets. So I've got the sum of my values squared divided by n minus 2 times the mean times the sum of my values, all divided by n. And at the end, I've got the sum of mu squared. But when I say sum of mu squared, it means basically that I've got n lots of mu squared. Okay, because each time for each value of x, I'm going to have to add a mu squared. Okay, and that's going to be divided by n. Okay, right. So you'll notice, hopefully, that the sum of x divided by n is actually mean. So I can rewrite this as the sum of x squared over n minus 2 times mu, or mu squared, plus, as you see, if I've got n lots of mu squared divided by n, that's just mu squared. But look, I've got minus 2 mu plus mu. So actually, that's equal to the sum of x squared over n minus the mean squared, which is the other form of the variance formula. Okay, so that's basically, that's how you get from one to the other. Okay, now the grouped, this is ungrouped data. If we have grouped data, then the formula is still sigma, the sum, but it's f times this bracket, x minus the mean squared over n. Okay, and I'll leave it to you to see if you can do this. Remember that f is going to multiply every term inside the bracket to get to a version of this.